Let's talk about this basic refrigeration trainer. And you're looking across from the far left. It's a compressor, a low pressure pipe and a high pressure pipe here. And here's the pipeline diagram of the system. This is the oil, gas and liquid separator. There are also pressure switches, storage tank drying bottle, pressure sensor. There are 2 pressure sensors. There is also a flow sensor for refrigeration. Here is the condenser and the evaporator, solenoid valve expansion valve. And then here is a screen of one message. And Ethernet. Here is a circuit diagram of the entire system. And there's a thermometer over here. Then the temperature control switch, temperature control meter, then voltage and current power meter. There are also start switches. Then there is a power port on the far left. Next, we conduct a power on test. We plug the power in. Turn on the leakage protection switch. Turn on the power again to start. Open ours again here. Evaporator and condenser. Compressor. I show this temperature above. This is the ambient temperature. The pressure above. Traffic. And the voltage and current of the compressor. Switch to this interface here. Is a faulty setting. This FE corresponds to the no E fault above. FR corresponds to fault no R. F3 corresponds to SAN faults. There are low faults in total. Prepare a network cable. Then read a message inside. It's basically what it looks like on the screen. First, open our software with our computer. Here is also a display with 8 temperatures. The 7th is 48 degrees. It's the same combination as this one. Here is an interface of a voltage. A graph of voltage and current. And this is stress. Then traffic. This is 1. Fault settings. You can click fault no E. Do a failure demonstration. Then pick a no E fault. Then click on the screen. Point E fault. Well, by now we've heard it very clearly. The compressor has stopped working. The compressor is faulty no E. It goes from the switch here to the thermostat. The thermostat is off. Then we measure the line. Check if there is any call. We hit the voltmeter. And then there's the 0 line. This is the line of fire. Let's test if there is any here. This is a circuit where voltage is not accurate. Normal is 220 volts. Let's go to buzzer gear. Measure its conduction. I found it was a broken circuit. Multimeters also have circuits. It's broken after we reset the switch. This is conduction. It is a conduction. Then the voltage is also available. The compressor is also working. So we're going to do a little demo. For example, let's break a no-R fault. It can find this. The condenser is not working. We use multimeters. Measure a measuring port on this side. Find the AC voltage meter. I found that there is no voltage here either. Measurement interrupt. Found out it was also a short circuit. Resistance infinity. It means that there is a break between this line and this line. When we recover the failure, the condenser is working. Then we measure the on-off. The lights are back on. Measure the voltage again. It's 220 volts. Later failure. Same thing. No signs for this evaporator. A malfunction. And fault C is controlling a compressor. The compressor also stopped. Fault No is also this line of fire for the compressor. We need to turn off the power after our training is completed. Put the power cord here and pack it up. Let's talk about safety in reality. We are in the process of practice. This condenser and evaporator. It does carry certain risks. The fan rotates at high speed. Do not stick in with your fingers or foreign objects. And here's a system diagram. It's also 220 volts at a time. We must pay attention when measuring. Pay attention to safety. Do not touch these metals with your hands. It's charged.